Data Skeptic features interviews with experts on topics related to data science, all through the eye of scientific skepticism.
So on Data Skeptic, I'm always looking for different types of guests from different angles. I like to cover the gamut of data science, not just stats and machine learning, but data governance, data provenance, data systems. I try and make things accessible, but pretty broad. I cover data ethics, which might not be strictly a data science topic, but it should be. Touch on data viz. And I want to do something about facial recognition. I hadn't really touched on it too much in the show, and I thought, hey, this is a major use case for data science, or at least it's a major application of machine learning. Let me find a really cool guest to do something about. And while I may still do that, I actually wanted to spend an episode here and talk more about a guest I found and haven't invited on, and perhaps I will or perhaps I won't, and I'll kind of explain why. Facial recognition has gotten pretty good, I have to say. I think most people would agree, especially anyone who's been watching the field for, maybe a decade or so. It's gone from being barely working to being pretty impressive. I think that's largely due to the availability of much larger corpuses of images, of faces, the computational power, the commodity hardware to process all of them, the GPUs that constitute a huge step forward in compute power, to some degree the algorithms we use, although I guess one could argue that the algorithms we use today were semi-obvious back then. We just didn't have the hardware to do them. But there's a big debate here, and this isn't really the right place to have it, but no one could argue with me that a lot has changed in the last decade, and facial recognition is ever-present and pretty powerful, though maybe not perfect. So I was looking around for who's doing something cool and innovative with facial recognition that is a little bit more than just a researcher who did a breakthrough, who has a cool story that I can feature on the show. So there was a company I found, I think it's a new company that caught my attention. Here's two quick headlines from their website. They say they are analyzing the crowd, finding your best paying customers. And they say, we predict online behavior from face images, as if maybe you worked at an online retailer and somehow you have a photo of your customers, or maybe, you were at a big box store and a photo comes in off the security camera. You're going to know something about that individual from their face. They say they do this by, quote, using advanced machine learning techniques we develop and continue to evolve an array of classifiers. I don't know what makes them advanced. If someone could explain to me the difference between an advanced machine learning algorithm and a non-advanced machine learning algorithm, I would really appreciate understanding the distinction. I think anything that works is advanced. Anyway, they go on to describe 4 particular personas they're able to classify. They say they can classify people as high IQ. They can classify academic researchers. They can classify professional poker players, which actually is the most plausible of the 3 to me initially. And then comes the 4th. They claim to be able to classify someone as a terrorist based on an image. So let me take a step to the side and talk a little bit about Data Skeptic for a bit. In fact, let's go back to the very first episode of the show there. I did this 3-minute introduction where I talked about kind of what I thought the show would be. Welcome to the inaugural episode of the Data Skeptic podcast, a podcast which discusses the applications, techniques, breakthroughs, news items, and science. In particular, I want to explore the plausibility of claims, celebrating the breakthroughs and the good science, while occasionally chastising the sensationalism and the, quote, magic proprietary black box, end quote, phenomenon. Well, when I went back to this, I didn't know if it would hold up because the show has, what I thought I would be doing when I started has evolved and changed a lot, as most things do. And I noticed I've only fulfilled on half the promise there. I have consistently celebrated cool aspects of data science. I haven't really done any of that chastising. There's not been a lot of finger waving on the show. In fact, I even had a few guests on that had what I thought were slightly dubious aspects to their results, but I thought it was an interesting conversation, and I'm not like, Michael Moore. I want to celebrate what's cool about data science and expose people to new things more than I want to tear it down. But I do think data scientists as a community need to be calling certain things out, and perhaps this is one of them. So I'm not going to name this company because I'm not trying to be clickbait or, go out and attack with someone. I just want to talk about this topic. And frankly, I may invite this company on to defend themselves. And I also feel if I don't do that, I can't really name them. I have to provide some sort of platform. So as you listen to this and this discussion, if you think this company would be a good guest, let me know. Hit me up on Twitter or Facebook or Go to dataskeptic.com. I'd love to hear what the opinions of the listeners are, whether it's worth going beyond the conversation I'm about to have and invite people from this company onto the show to defend their product. Now, I'm only going to do that if they will talk details to me. I don't want to talk to a marketing person who gives me doublespeak, but perhaps it would be interesting to allow them to tell their side of this. Because I want to explore this claim, can machine learning use facial images to detect terrorists? Let's say they left the last one off. Let's say they were just going to detect people of high IQ, people who are academic researchers, and professional poker players. I might let that slide. As much as I kind of would criticize it, that that's even possible, marketing fluff gets stuck into a lot of these things. I've even seen it happen with work I've done. Some companies, the ones that are better at the fluff, seem to describe the product not as it is, but as it might be in 6 months. And while I'm sort of personally critical of that, maybe that's the right way to do it. Maybe it takes time for a message to sink in. So maybe you describe the future such that by the time people hear your message and respond, it matches the reality. But I'm unclear how any amount of continued R&D is going to make it possible to detect terrorists with just facial recognition. That's the other key to this. We're not talking about other features. If you told me there was some social network analysis that had a pretty good reliability of finding a terrorist, or some analysis of cell tower, SMS and stuff, I'll give you a real quick maybe. There's a certain plausibility to that. So how do they claim to do it? Well, they actually don't. The website doesn't say anything about the methodology. There's no white paper. There's nothing on the archive that I could find related to this place. But I can take some guesses. I know more or less the state of the art of facial recognition and image processing. So let me share a little bit at a high level with you for those who may not know. How do you use machine learning to learn something about images? Well, what's an image? It's a collection of pixels. A pixel has an RGB value, although you can represent that in other ways. Most image recognition stuff, I don't know about most, but much of it, everything I've done, you convert that to a grayscale right away. So you're looking at the intensity of pixels, and the pixels are more or less generated from the sensor array of your camera. So on some level, you could take each pixel, its grayscale value, its intensity, and represent that as a value from 0 to 1, or any numeric value actually. And you can plug those directly into a machine learning algorithm. So what's a typical image size? At least, I would say 300 by 200 pixels to even be able to look at much of it. Most images are much larger than that. If you just took that large array and considered that your feature space, and then threw a random off-the-shelf machine learning algorithm at it, let's set deep learning outside of this for now. Just say you threw logistic regression or random forest at it and said, here's 1,000 images of dogs and 1,000 of cats, and here are all the pixel intensities. Try and learn a mapping from these image arrays to this binary classifier, dog or not dog. So the problem with that approach is we have a nonlinear function we're trying to recognize. Every machine learning algorithm is essentially performing an optimization. It's trying to find usually like a minimum point. So picture for yourself a parabola, or maybe not a complete line, just a sample set of points, and try and find the minimum of that. It's probably quite easy. You can do it with your eye. But imagine if you had to do that over 3 dimensions, 4 dimensions, 100 dimensions, and realize that the dimensionality we're talking about is the length times the width of the pixels at a minimum. This is a highly dimensional problem for which we have many, many more dimensions than we have example cases. There's also the fact that it's a noisy data set. So it's unlikely we're going to tackle that problem directly by just arbitrarily pumping all of those pixel values into an off-the-shelf machine learning algorithm. Something else has to happen here, and that something is a form of abstraction. Imagine if you had a software program, you don't know how it works, but it's a black box that looks at images and recognizes certain things about them. It says like, well, this is an image that has fur in it, or it has whiskers in it, or it has a tail or a chew toy. These are features that would be very useful in determining does this image have a dog or a cat or some other animal in it. Those are aspects of knowledge representation. And a lot of image recognition is about the automated process of knowledge generation, automating feature engineering. And while if you deconstruct that image recognition algorithm, you might not necessarily find, the exact weighting and pieces of it that represent the detection of fur or a tail, there are some meta features that are detected that at each layer make that possible. So you're not trying to learn the whole problem at once, you're trying to learn pieces of the problem that are building blocks to a larger solution. So how do we do it as humans? Well, we see it at a more abstracted level. We don't see individual pixels, mostly because, on modern retina displays we can't anymore, but I at least grew up with a computer where I could see the pixels. but I saw past the pixels to see bigger ideas, even when those were images of, Super Mario Brothers, who were very small number of pixels height and width. So I won't get into here the theories of why, mostly because I'm not strictly an expert in them, but there's a cortical hierarchy in our visual cortex that we're essentially emulating in a lot of deep learning technologies. There's no grandmother neuron. It's not that we're recognizing things at the pixel level. We're at different layers recognizing different things, from edges to shapes to compositions, and you sort of more or less build up the building blocks. So it's like every one of those layers is an independent machine learning test. At the lowest level, maybe you're training a model that learns just where the edges of things are. Above that, you're learning what edges make what shapes make what figures, what nuanced figures look like in, different rotations and scales, and so on and so forth, till the point where we can recognize our friends, and we can recognize a line drawing as a caricature of a famous person. Our visual cortex providing us several layers of abstraction so that we don't see the individual photons hitting our retina. We see higher level things that our brains are finely tuned to recognize in a hierarchical fashion. So machine learning has to transform those pixels into something else. Largely that's through attempts to emulate that, whether, as I said, it's deep learning trying to more or less copy that same hierarchical process, or we first convert the image into a different space, like maybe we run it through a Gabor filter and then we have data in the Gabor space, or we apply wavelets all over the place so we extract different representations of the data that we can learn on better. So my view from 50,000 feet is just to say that image recognition is about a hierarchical process of building up different meta features at each layer that constitutes some scale of abstraction, so that you're not trying to learn a massively multidimensional problem, you're learning from the features generated at the layer below. Now, if you've never done a problem like that, an image recognition problem or a really high dimensional problem, or work with system telemetry or something like that, if you've done more traditional machine learning, maybe you work for a company and they give you details about a credit card transaction and you're trying to predict fraud. You look at things like, has this person ever dealt with this merchant before? That's a nice feature. How far is this purchase from their home? Is this at a risky establishment where a lot of fraud goes on, like gas stations and strip clubs, or is it at the grocery store that's near the person's apartment? These are all intuitively good indicators that you would pursue as features. And the problem for someone working in machine learning is largely about knowledge representation or feature engineering. And it tends to be hands-on in that case. You can sort of identify what each of those are, but imagine if you had massive amounts of them. And you're not going to identify each individual pixel, you're going to identify features of how they're grouped together. So it's a different area, but it's all the same sorts of technologies, but different approaches and algorithms tend to favor one of those domains or the other. But let's get into the skepticism, this being data skeptic. Machine learning is not magic. I mean, it might be in the Arthur C. Clarke sense of the word, but it's not intrinsically breaking the laws of physics. It's not doing anything that is undoable. Now, machine learning is obviously outsmarting human beings. It's beating us at checkers and at chess. Although you might actually claim that a person was beaten at Go recently by not a machine, but a machine and some very smart people that built that machine. But that's neither here nor there. Let's play a variant of Alan Turing's famous imitation game. Imagine if there are two observers who are looking at photos. One is a model trained by a machine learning algorithm, and one is a human being. And they are shown faces and asked to determine, is this new face a terrorist? How good do you think you could do? What if this was your full-time job? You looked at pictures every day, all day, and you had to, and you were trained. You were saying these are some terrorists and these are some non-terrorists. You were asked to learn to recognize who's a potential terrorist or not. Now ask yourself, do you think you will be more successful at your job than that computer will? Now forget about the terrorism stuff for a moment. Let's just say you and the computer were competing to recognize something about a customer. Like a retailer hired you to look at the photos of everyone entering the store and guess, is this a person who's going to make a purchase today? Could you be successful at that? Yeah, I don't see why not. I don't know exactly what I'd look for, but you'd probably pick up trends. If the retailer is selling ice cream and someone comes in really hot and sweaty, yeah, maybe they're going to buy ice cream or a cold bottle of water. Or if you see someone coming in, they're, on their phone, checking their watch, they're just killing time to wait for someone. Sure, yeah, you could, with some reliability, start to predict, better than chance, at least. Yes, that's a customer that will or won't purchase something. And I think we could take that even further. Look up a picture of me. I'll give you permission to make all the prejudices you want about me. Go to images.google.com, type in Kyle Polich in case you don't know what I look like. Oh wait, actually, let's double check. Make sure my photo comes up. Okay, yeah, there's a bunch of pictures of me in the first row. There's a random coworker. That's kind of weird. There's Nikki, the second ever guest to the show. Somehow she ended up here. There's another guy who is also named Kyle Polich that I've never met, but I know about. Oh, there's Dave Ingram from the Personalization podcast where I was a guest, and Felicia Gopal when I was a guest on her podcast. More random coworkers. Oh, there's a picture of me talking at the Montgomery County Skeptics. I'm actually going to be talking again early next year, so come out and see me there if you're in Northern California. Really looking forward to that talk. Oh, there's Carl Maimer from Conspiracy Skeptic where I appear. There's Seth Shostak, which is interesting. I have sent emails to Seth, and he's graciously replied, but I don't think we're in any way publicly connected, so I don't know how they've linked that. That's interesting. But clearly Google is doing something with social network. The fact that they've linked me to a lot of coworkers, for example, must mean there's something tied in through LinkedIn or who knows what. Which actually, this is a really cool topic. I'd love to talk to an engineer who manages the search results at images.google. But you can find my picture there. Go ahead and make prejudices about me. I give you permission. Am I someone that's going to buy tickets to see the Slackers or to see Onyx? Am I going to listen to a Jeff Foxworthy comedy CD, or do I want to listen to Kyle Kinane's Whiskey Icarus? Am I going to watch a video about skeet shooting or one about Arduino programming? Now, this is a bit unfair, because if you've listened to the show at all, you know a fair amount about me. Even though I've never explicitly said it, you could probably easily guess from the audio of the show that, I support the Electronic Frontiers Foundation. But if you didn't know me, you just saw this picture, you could make a lot of prejudices about me, that maybe it's not a nice thing to do, but you could make some truthful ones with some amount of accuracy. Now, this is also making me a bit uncomfortable because this can amount to some sort of profiling, and there's a lot of ethical questions to be asked. I don't want to tackle those here, at least not the hypothetical ones. I think they are worth talking about in the context of, can we detect terrorists? So here's another quote from this company's website. They say, this is a quote, "We encode facial appearances in proprietary image descriptors and train state-of-the-art machine learning algorithms to predict personal traits, capabilities, and online behavior." Let's talk a minute about the word proprietary. I'm not very fond of this, especially in a situation like this. I think if people are to be profiled and potentially labeled or screened as terrorists, there ought to be, whether or not we should do that at all is a worthwhile question to ask. I'm not saying yes, I'm not saying no, but certainly that code should be open. We should be able to inspect how it claims to be doing that. And I say this not so much from a social perspective that I think that's, has anything to do with human rights or anything, but because I've seen a lot of these proprietary algorithms. I've signed a number of NDAs in my life to work on things like that. And there have been cases when I signed that NDA and then saw code and was truly impressed and said, yes, you guys have something here. It's really good, and you should keep quiet about how you did it because it's clever and maybe no one else will figure it out. I have also seen more cases of signing NDAs where the only real secret I'm keeping in being respectful of that NDA is to not tell you that the emperor is not wearing any clothes. I have literally seen things that were called proprietary algorithms that were basic equations expressed in Excel. Now, that's fine. I'm not going to call anyone dishonest about that. I'm obviously not naming companies. If you want to use that as a marketing ploy, that's fine. I personally would rather be sold on a demonstration over a claim. But if people go around making silly claims, it presumably will be harder for them to get business. So maybe things are self-selecting. Maybe we don't need to worry about proprietary algorithms. But what about when they affect people in important ways? So here's another quote from this site. "Working with face images only, blank company name, automatically and reliably predicts personality traits, capabilities, and online behavior." Well, we have to define what reliably means with what accuracy. And like I said, this problem isn't impossible, but it makes me uncomfortable when you're predicting something like, is this person a terrorist? Or even, is this person likely to commit fraud? Do I have the face of a terrorist? What about Ted Kaczynski and Osama bin Laden? Well, they both have beards. Wait, maybe I cracked the problem. No, Timothy McVeigh, no beard. Well, the training set of terrorists is very small. This is a problem we call an imbalanced data set. I don't know what the count is, and I hesitate to guess because I'm afraid I would actually sadly undercount, but let's assume there's, 100 photos of confirmed terrorists versus however many billion people are on the planet. This is a really imbalanced data set. Anyone in your training set is certainly a known infamous person. And by that account, you could actually say, well, I've made a classifier. In fact, just now I made a classifier that predicts terrorists with 99.9999% accurate. You know how I did it? I just assume every person is not a terrorist, and I will be right almost all the time. Now, I imagine this company that built this product would claim that they bias towards false positives over false negatives. In other words, it would be better to flag a person as a potential terrorist than not flag a true terrorist. Because then I guess you can screen people, and in the screening process presumably has more precision. So you can't screen every human being. So if we just filter down to the smallest, in fact, yes, I'm going to pretend I work for this company. Here's how I say it. We don't detect terrorists exactly. We help you we speed up the airports. That's what you tell them. There's all these complaints about the airlines being too slow and the TSA being too slow. This is a technology to speed that process up. This is great, right? Yeah, it's going to let most people through. It's just going to flag some as maybe a terrorist, and then we'll screen them. But how is it going to do that? This feels very dangerous to me as outright racism. Take a look at that technology that John Morrow described on a couple episodes ago. John is the guy I was lucky enough to talk to who's from eHarmony. He talked about face parts, just actually sort of briefly. It's a technology they built. Even if you're not a programmer, go to their webpage, look at some of the output images. There's a picture of John and all the face parts. These landmarks are labeled on his face. And you can see where there are aspects of his cheekbones and his nose and his chin and all these things. And it's really pretty powerful at finding areas of people's faces. So imagine you took that as your first step. You're going to build an ensemble model. And you get all these facial points. You could probably build a detector that identifies people's nationality with face parts. I'm able to, with some amount of errors, guess people's sort of nationalities. I'm not always right, but there's something I've learned. My neural network has figured out, like, high cheekbones and the eyes this way and the forehead and the chin and this and that. And I can say, like, I think that's a person whose heritage is from this or these countries. I can do that with some reliability, and it wouldn't surprise me if you took face parts and you built a nationality detector, which in and of itself is not an unkind or inappropriate thing to do. It's how you apply the technology that counts. So as far as I know, and again, I haven't looked at statistics on terrorists, take whomever you want to call a terrorist and get those pictures, and that's your training set, or that's your labeled as yes terrorist, and then random images is not terrorist. And I suspect your pile of known terrorist images will have a racial bias to it. So one thing that is plausible that could happen here is you develop an algorithm using landmarks of a face that identifies the race of a person. And if for some reason in your training set, that particular race correlates highly with what you've chosen to provide the training examples of terrorists, there's a good chance, or there's certainly the possibility, of doing machine-driven racial profiling. And worse, this is something that could happen, I think, on accident. I think it's possible that someone who doesn't know that much about machine learning could get this system functioning, compiling and running, and appearing to come out with a model. Someone not quite informed enough about machine learning to understand these risks. If you haven't, I would recommend everyone go back and listen to the episode where I interviewed Christian Sandvig. Christian has a lot of great ideas about auditing algorithms, which is the title of that episode. We don't touch on this specific topic, but he's someone who I actually should ask for his comments on this. I'd love to hear what he has to say. He talks a lot about how do we audit algorithms? What are the procedures to do that? Why should we do that? And this is a case where, in my opinion, some auditing should be necessary. But if it's proprietary code, as the company describes it, we won't be able to do that, at least not directly. Maybe we could submit a data set and see how it turns out. But then again, how do we submit a useful prediction? If someone pretends to be a terrorist and says, take the picture while I look doing my best terrorist impression, one could easily claim that the machine is detecting true terrorism, not staged terrorism. Now, in an extreme case, if someone has like a dynamite-shaped bulge under their clothes and it looks like an associate of the Wile E. Coyote, then you could build a machine learning system that detects a person that looks that way. But all we have is these facial images. So what is it they're actually detecting? I think it's fair for me to claim that if this were to work, there's some meta feature that is being recognized by that system, not at the pixel level, but at some layer of abstraction. So what is it that a machine learning algorithm might see that a human being couldn't see? Is there a glint in the eye? As a skeptic, I have to admit, I do know my vision is faulty. There are some great videos by Richard Wiseman. Watch the basketball video if you haven't. You can absolutely be fooled. I once watched a YouTube video about movie mistakes, movies I'd seen, And then they highlighted things, ridiculous things that were going on in the background or just errors that I didn't notice. I saw the movie, had to be pointed out to me. Illusionists and magicians, they fool me all the time. Maybe there's something I don't see that an image recognition algorithm could, but what would it be? Because when an illusionist shows me their trick, if they'll do so, I can see the mechanism by which I was fooled. What about this idea of micro-expressions? If you haven't heard of it, it's the idea that apparently humans are doing very fast, subtle twitch expressions that reveal our true intentions and it's subconscious, something like that. Stephen Novella on the Neurological blog, in a post titled Lie Detection, goes into this and pretty thoroughly debunks it. Now, there's one interesting thing he does raise is that there's potentially the possibility of building an fMRI lie detector. Apparently, brains go through a different process to fabricate than to recall, which actually makes a lot of sense to me. Even these micro-expressions, while dubious though they might sound, and there is no good evidence for them, Dr. Novella says they're not necessarily well studied. Perhaps they could pan out, but they're also something that you see in video, which is again not what we're talking about. What could possibly be actually detected? The fact that someone's sweating because they're nervous? Maybe they're just in a hot city and they ran up a bunch of stairs and they're out of shape. There's a situation in the UK. A company developed a device called the ADE 651. It proclaimed to be a bomb detector. It was made by a company called ATSC, and governments spent millions of dollars on this thing that was a complete fraud. It was based on dowsing rods, essentially. It had no basis by which it could possibly detect a bomb. Now, there's a long story about the fallout from that. Luckily, I believe the supposed inventors or the people from that company are now in jail. There are good questions to be asked about why governments and militaries were buying these things in the first place without testing them. But if people will buy nonsense bomb detectors, then surely they'll buy and trust nonsense machine learning algorithms. Machine learning works really well. Its impressive results are all around us. And it would be pretty easy for someone to abuse the trust that people have had in the ability of these techniques to do good work. So it's hard to prove a negative. With nothing in my hands but the marketing materials of a website, I can't definitively say that they're not able to do this. But I can say by any mechanism I could possibly think of, this is a really dubious claim. Even the idea of using external data, the social network kind of analysis, other features, seems maybe dubious to me for detecting a terrorist. First and foremost because it's such a rare event. With a finite and limited set of actual terrorist photos to provide, there's a good chance of overfitting the data. You could surely make a system that has the ability to recognize known terrorists from everyone else. After all, we have facial recognition that can recognize individual people. But that's not that useful. If we have a picture of a confirmed terrorist, it means they've already committed an act of terror. We'd like to find a leading edge predictor, not a falling edge predictor. Let's also put one argument to the side. Perhaps this company would say they're only going to do facial detection of known confirmed terrorists in the same way that Facebook detects who appears in photos. That technological claim is not unreasonable. Yet we know there does not exist a database of people with high IQs, nor is there necessarily a database of everyone who plays poker, nor academic researchers, which are their other two use cases. So we can conclude that the company is implying they're doing a classification on unlabeled data, not a lookup to an existing database. So if there were, let's say an official brand of glasses worn by all and worn exclusively by terrorists, then yes, we could probably detect terrorists from facial recognition by detecting this correlated feature of these terrorist brand sunglasses. I mean, it does depend on your feature space, though. If you somehow in your work manage to get a feature that labels every airline passenger as to whether or not they got through security with explosives, that would be a great feature. That would have a lot of predictive power. There's only a handful of explanations. Either you're the fire marshal and you have a gun that has technically an explosive in it in the form of the gunpowder, or you're some fireworks enthusiast who broke the law and brought fireworks on board to take home, or you're a person with an actual bomb. And maybe there's a few other bizarre corner cases, but very few people would try and bring explosives on a plane. Very few people would make it through security. But yes, if that were a thing and if you could measure it, then it would make a great feature. But that's exactly what would be required for this to work. You'd have to have some mechanism, some transformation or some activation function or something that emerges a useful feature from the images that helps you detect terrorists. That useful feature, by definition, must be there in the image. And as I said earlier, machine learning is not magic. So I ask a lot of guests the sort of stock question of, in your machine learning application, were there any features that surprised you? And sometimes I cut out the answer because most people more or less say no. You can go back and listen to the eHarmony episode where I asked John Mora, and he paused for a while and was like, not really. And I think that makes intuitive good sense to me. He is solving a dating problem. And while, as we joked, he might not in the first go introduce you to the, lasting love of your life, which actually isn't necessarily his goal anyways, at least there's an intuitive plausibility to everything he's found useful. And I see that across the board in most machine learning applications. If anything, people might be surprised that the features are ranked a bit differently. Or sometimes people will pull out random noise or spurious correlations and report on them when they have a humorous angle or some human interest angle someone was trying to spin. But I'm baffled as to how this could possibly work. Could you show me pictures of high school students and determine whether they were on the football team or the marching band? Yeah, that's somewhat plausible. People present themselves in certain ways. If I as a human can do that with some accuracy, then certainly a machine can match me. It might take time, research, maybe some breakthroughs, but I'm not doing anything that a machine can't do. But could I detect a terrorist based on a facial image alone? I can't imagine how I would do that, and in turn I can't imagine how a computer would do that. There are other claims, someone with high IQ. Well, IQ's not a good measure anyways, so maybe. Someone who's an academic researcher. That's a weird one, but maybe. Professional poker player. Now that one I believe. I think maybe poker players conduct and present themselves in a certain way. They're all about the tell and the privacy and the caginess. Maybe that's possible. I'll tell you this. I used to be pretty active at playing the trumpet. And some people, you build up lip muscles that normal people don't build up. And I can spot a trumpet player sometimes from their face. I don't know exactly what I'm doing. I just do it. I just say, hey, there's something about their lips that looks different. And they look like the way mine used to when I actually practiced. But that's an actual physiological thing that I train myself to detect. That's the sort of things that image recognition gets good at. And while maybe that was this superpower I had that the average person can't do, my ability to do it was not magical. So the same company making all these claims goes on to say that they scanned the photos of the Paris attackers, and they claim that they got 9 out of 11 of them flagged as attackers. And they're trying to use this claim to garner interest and contracts with governments. We could have found 9 out of 11 of the Paris attackers is their essential claim. You need to hire us. You're irresponsible to not hire us. Those are our tax dollars, the data scientists and the non-data scientists listening. So I'm of the opinion that if such a contract were to exist, there needs to be an audit. Although it's worthwhile us expressing our opinions as a community about this to those in power who might purchase these things. And if you think that no one's so silly as to think that this is possible, look up the ADE 651 unit, the fake bomb detector I mentioned earlier. So I apologize, everybody, for the little soapbox episode. We're moving this week, and schedules just couldn't be coordinated, but I did want to put something out. I hope you like this discussion, and I would love to hear from everyone their thoughts on this. Is it even remotely possible to think that machine learning could be used to detect terrorists based on facial images alone? And do you think I should invite this company to come on the show and defend their claims? Let me know. And until then, keep thinking skeptically of and with data.
For more on this episode, visit dataskeptic.com. If you enjoyed the show, please give us a review on iTunes or Stitcher.